Hi everyone, this is Dr. Kiranmayee, working as professor in the Department of CSC and also in charge for the technical trainings at VNR VJEC. So today I am going to discuss about one of the application of the stack, that is in-fix to post-fix conversion. In the previous video, we have seen one of the application of the stack, that is conversion of an in-fix expression to the post-fix expression using stack. So this is the second application of this stack. So what is the role of a stack when you want to evaluate a postfix expression? Why it has to be evaluated? So if you take an expression a, b plus, so here the input is a postfix expression, right? So now this one I need to evaluate it. So manually you can evaluate it if it is a very smaller expression, but if at all it is a complex expression, then we have to use a stack. So I said the stack, one of the stack application is the evaluation of postfix. So the postfix expression is evaluated using a stack because it removes the need for what? The operator precedent, and also no parentheses are there. It is a parenthesis free expression. So very easy to evaluate that type of expression. And the stack provides a very simple and efficient way to store only the operands and perform the operations in the correct order. So suppose if you take this AB plus, okay, so this is an algorithm for a stack. So what is the first step? Add a right parenthesis to the postfix expression. So what I add a right parenthesis to the postfix expression. So suppose A value, suppose I assume it as a 3 and B value is, suppose it is 5. So this is, I need to evaluate 3, 5 and plus. So 3 is one operand, 5 is another operand and plus is an operator. So first we work with a very small example. In the later slide, we go for a very complex example. So first step is add a right parenthesis. So I have added a right parenthesis at the end of the expression. Read the postfix expression left to right until right parenthesis is encountered. Means you need to move from left to right and scan each and every operand and operator. Now, if at all, third step is what? If operand is encountered, push it onto stack. Now, suppose we assume this as a stack. Okay. Now, initially, your stop will be over here. Okay. So, what I mean to say is, if at all an operand is encountered, push it onto the stack. So, first is what? Operand is encountered. So, push it onto the stack. Then, increment your top. Then, if operator is encountered, pop 2 elements. No, so next one is also an operand. So what you have to do? If an operand is encountered, you have to push it onto the stack. Okay, then your top will be incremented. Now, if operator is encountered, so next one is what? Operator. So you have to pop the top element and say it as A. So now what is it? A is nothing but equal to 5. And then B is the next to top element. So this is again pop it. Say this is equal to 3. So now evaluate B operator A always. Here, why always you are going to evaluate B operator A mean here plus A plus B or else B plus A is the same. But A minus B and B minus A are not same, and also A slash B, B slash, that is division, is not same. So that is the reason this step has to be followed. Evaluate B operator A only always. So evaluate B operator A. So nothing but 3 plus 5. So push B operator A onto the stack again. So what is the resultant now? These two will be deleted. Now you have only 8. Okay, perform the operation and push back the result back onto the stack. Now here set the result is equal to top. So this is nothing but the result now. Now, what I said, whenever a right parenthesis is encountered, because 3 is scanned, 5 is scanned, plus is scanned. Now the next scanned element is what? That is the right parenthesis. Whenever a right parenthesis is encountered, that is means you have the result on the top of the stack. So you pop it and just print the result. So this is about the algorithm to evaluate a postfix expression. So now we see another 2 examples which is going to evaluate the postfix expression using the stack. So now we have 5, 6, 2 plus multiplication 8 minus. So first step is add a right parenthesis to the end of the expression. Now if an operand is encountered, you have to place it on the stack. What is the next symbol scan? 6. 6 is a symbol scan, then you have to again push it onto the stack. Next is again an operand, again push it onto the stack. Now, what is the current content of the stack is 5, 6, 2. 2 is on the top of the stack. Next, if an operator is encountered, what do you have to do? You need to pop the top 2 elements. So 2 you say it as A and 6 you have to say it as B. Now what you have to do now? Perform B operator A. So B plus A you need to perform. That is 6 plus 2. So 6 plus 2 is performed. Again push back the result. So 8 is pushed back onto the top of the stack. Next symbol scanned is multiplication. Whenever an operator is encountered, again, what is this step? You need to pop it, the top 2 element, say this as A and this is B, perform B multiplication A. And again, push back the result onto the top of the stack. Now 40. Now see whether any other symbol to be scanned is Z. Okay, so yes, 8 is Z. So if an operand is encountered, push it onto the stack. Next is what? Minus. See here. Minus. Operator is encountered means again you have to pop it from the stack. Perform B operator A. B means 40. B means 40 and then you have a 8. So 40 minus 8. So 32. Next operator to be scanned, next operand to be scanned or symbol to be scanned is what? Right parenthesis. Whenever a right parenthesis is encountered, that means what is on the top of the stack is nothing but the result of or the value of the postfix expression. So 32 is the answer for this input postfix expression. We have another example. We take a very larger example this time. 9, 5, 3 plus 8, 2 minus multiplication 4, division and plus. So first step is what? Add a right parenthesis. Now the first one, if at all an operand is encountered, push it onto the stack. Next symbol to be scanned is 5. Yes, push it onto the stack. Next is 3. Push it onto the stack. Next is operator. So whenever an operator is encountered, you have to pop the top 2 elements and perform B operator A. So 8. 8 is again pushed back onto the top of the stack. The temporary result has been pushed onto the stack. Next symbol scanned is 8. So 8 is pushed onto the stack because it is an operand. Next is minus. So whenever minus means operator, now you have to pop it from the stack, the top 2 elements. So you have to say 8 minus 2. Push back the result again. So 6 is pushed back. Now the next is again an operator. Operator is encountered means what? Again pop these 2 elements. Then perform the multiplication and push back 48, that is 6 8s are 48 onto the top of the stack. Next is 4 operand. So pushed onto the top of the stack. Next division. Division, now you have to pop it from the stack 48 and 4. So then you perform 48 division 4. Next 12. 12 is pushed back onto the top of the stack. Next symbol is addition. operator. So again 9 and 12. You have to pop it and perform the addition and push back the result onto the top of the stack. And the last symbol is scanned is a right parenthesis. Whenever a right parenthesis encountered, that is the end of scanning the postfix expression. So means the value which is on the top of the stack is nothing but the answer which is generated for the given postfix expression. So for the evaluation of postfix expression, input will be a postfix expression. And what is the output? Output is a nothing but a value which can be an integer or it can be any real value with the decimal point. Now, here are all these examples given. So I hope you all do with the algorithm whatever it has been showcased in this particular slide. So thank you all and wait for the next video to become. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.